Assalamualaikum and good day, ladies and gentlemen. You are currently with me, Siti, in my final year project presentation entitled Analysis of Vertical Particulate Matter Profile along with the height at SNP Tower, UiTM Shah. In this study, PM10 and PM2.5 are the main focus air pollutants. PM are most likely to be detected and most dominant in urban environment. The vertical profile is crucial because it can determine PM at various heights, giving specific information about its origins and dynamic transport. The increase of the height from Earth's surface will decline the rate of particle concentration. Now, ladies and gentlemen, what problem inspired me to do this project? In Malaysia, the expanding and growing of industrial activities, vehicle usage, and energy production causes the degradation of air quality in urban area. Unfortunately, the study of vertical PM concentration is still obviously lacking and have a little understanding on PM behavior with the increase of height. The vertical profile may help better understand the behavior of pollutants, meteorological conditions, atmospheric boundary layer, and their relations. My aim for this project is to measure PM10 and PM2.5 concentration in a vertical profile at different heights from 27.16 meter to 95.38 meters using air quality monitor sensor, and then to determine the relationship of height factor in PM10 and PM2.5 vertical profiling using Pearson correlation analysis. Let us move to literature review session. Shah reported that there is a significant decrease in PM concentration reading at its far from the ground. And then Azimi found that PM concentration decreased when recorded at the upper level of building height. Based on Meng and Wang, the long-term strong temperature inversion layer and lower troposphere or atmospheric mixed layer height can result in continuous accumulation of pollutants. Also, based on Liu, there are 6 categories of humidity level. Relative humidity more than 70% can reduce the PM concentration. For methodology part, we choose suitable high building, which is SNT tower at UiTM and air quality monitor. We also conducted the sampling over 6 days with 3 times sampling periods such as morning, noon and afternoon. After that, we obtained the data of PM2.5, PM10, temperature, relative humidity and wind speed at selected height. After we collect the data, I do Pearson correlation analysis on PM2.5 and PM10 concentration along with the height. And then, this is the site layout of SNT tower. This is the air quality monitoring instrument that we use to obtain the PM concentration. Then, we move to result and discussion part. The overall PM2.5 and PM10 concentration during the morning were recorded at 13 picogram per cubic meter and 17 picogram per cubic meter. During the noon sampling period, the overall PM2.5 concentration was recorded at 14.33 microgram per cubic meter to 14.99 microgram per cubic meter, while PM10 concentration was at 18.55 microgram per cubic meter. Lastly, during the afternoon sampling period, the overall PM2.5 concentration during the afternoon has 2 readings recorded at 6.33 microgram per cubic meter and 11.27 microgram per cubic meter. Meanwhile, PM concentration was at 7.67 and 14.22 microgram per cubic meter. Next, we go to the second part. This is the graph for variance on the vertical PM2.5 and PM10 profile at different time period against the height for 6 days. First, at the morning sampling period, PM2.5 and PM10 concentration mostly shown an overall trend of increase and then decrease. Then, during the noon sampling period, the PM2.5 and PM10 concentration show an overall trend of increase at first, then decrease, and then it gradually increase again. Lastly, during the afternoon, PM2.5 and PM10 concentration mostly shown an overall trend of increase at first, then decrease, and is steadily increase but is still in a low concentration. We move to the third part of the result and discussion. The figure shown is the plot of the average PM2.5 and PM10 concentration against height in 6 days. The lowest PM10 and PM2.5 concentration was recorded at the height of 95.38 meters. For example, 11.11 microgram per cubic meter for PM2.5, 13.99 microgram per cubic meter for PM10. Meanwhile, the highest PM2.5 concentration was recorded at 14.88 microgram per cubic meters, which is recorded at the height of 86.2 meters. For PM10, the highest concentration is at 80.5 microgram per cubic meters, which recorded at 43 meters. Wang stated that the temperature inversion happened at a lower height, likely to block the newly formed ground PM to disperse outward. During the morning sampling, the ground temperature is quite cold. Similarly, Howe stated the inversion layer acted like a lid, which inhibited the pollutant at the ground to disperse outward. Next, during the noon sampling period, the lowest PM10 and PM2.5 recorded at the same height, which is 57.4 meters. For example, 13.72 microgram per cubic meter is PM 2.5 concentration, and 16.66 microgram per cubic meter was for PM 10 concentration. Meanwhile, the highest concentration for both PM is located at 95.38 meters. For example, PM 2.5 concentration is 70.22 microgram per cubic meter. And then PM 10 concentration is at 90.77 microgram per cubic meter. The solar radiation intensified and ground temperature also rapidly increased, which destroyed the inversion layer near the lower height. The temperature inversion very higher in the noon, which was favorable to dispersion of near ground PM 2.5 and PM 10. Similarly, a study made by Liu stated particulate matter was more homogeneous during the noon than in the morning. In addition, this can be associated with the involvement of human activities, whether emission from industrial plants and vehicle combustion near the study area. Lastly, during the afternoon sampling period, the lowest PM10 and PM2.5 concentration was recorded at 86.2 meters. For example, 11.27 microgram per cubic meter for PM2.5, 14.22 microgram per cubic meter for PM10. The highest concentration of both PM was recorded at the same height, which is 27.116 meters. For example, 15.77 microgram per cubic meter for PM2.5, 19.8 microgram per cubic meter for PM10. The concentration most likely would settle down near the ground if the temperature inversion slowly decreased before 6 PM in the afternoon. Presence of cold air and wet environment really affected the increase and decrease of both PM concentration. During the sampling, the relative humidity level was around 69.6% to 76.22%. Some stated that if the relative humidity was higher than 70%, then it could decrease the PM concentration. In addition, during the afternoon, it was very windy and have cold environment. High wind speed value can decrease the PM concentration whether at the ground or at the upper region. I will go briefly on the percent correlation analysis. For the morning sampling period, the R value for PM 2.5 was at negative 0.424 and PM 10 was at negative 0.658. For P value, PM 10 recorded at 0.078. Meanwhile, PM 2.5 0.201. It means it has no significance between both PM with the height during the morning. Next, for the noon sampling, the R value for PM 10 and PM 2.5 are at 0.316 and 0.492. Meanwhile, for P value, PM 2.5 recorded at 0.161 and PM 10 recorded at 0.271. It means it's no significance between both PM with height during the noon. Lastly, for the afternoon sampling period, the R value for PM 10 and PM 2.5 at negative 0.867 and negative 0.908. PM 2.5 and PM 10 value was recorded at 0.006 and 0.013, which means it has statistically significant correlation between both PM with height during the afternoon. For conclusion, the PM concentration does decrease at the upper region of troposphere. However, during the noon sampling, it increased at the upper height because meteorological conditions heavily influence the distribution of particle profile. In this study, only during the afternoon sampling, I have concluded that PM concentration and height have statistically significant correlation. For recommendation, more research on vertical air pollutant should be encouraged as it's still new in the vertical profile study on air pollution. Also, it's best to use proper instrument when taking the vertical particulate matter profile. Lastly, the study should add more meteorological variables such as temperature, humidity, wind speed, wind direction, as it heavily influence the PM concentration.